Okay, I'm hoping the other classes are ready to begin here in a minute.
Alan's class is ready.
It's okay, Rebecca. You could always, when it's time for paper, you could always borrow a piece of my paper.
Lewis's class is ready. Miller is ready.
All right, so we do have our books open to page 202. We don't need to be peeking in them yet. We do have our pencils put down, and we're going to go ahead and start out our very first algebra lesson. Okay, sounds scary, but it isn't. Trust me, this is actually something that you guys have been doing, skills you've been doing since you were in the second grade. Some of us, yeah, maybe even in first grade, they start doing some algebra, okay? They just kind of sneak it in there and they don't call it algebra. This has no sound, this video, okay? So don't worry about hearing it, just read it. I just pause it here because it gives more people time to read the whole thing. Okay. So as you can see, there's this strange looking word here. Okay, that's the guy that you can blame. I mean, thank for algebra. Go ahead and read that box. Okay, so this gentleman here, his name is again, Muhammad is his first name. This is his last name. Okay, he is the father of algebra. And he was born recently or not? A long, long time ago, wasn't he? Okay, so this isn't new math. This is not new math. Okay, so if your parents are telling you this is all new, tell them baloney. This dude, he was born in 780 AD. It's old math. Okay, now it says right here that this is all happening in the east of Persia, right on the legendary ancient Silk Road between China and Rome. Okay, Mrs. Franzen was helping her daughter this weekend with her homework that she had to catch up on because she missed a day of school the week before Christmas break. And they are actually in the 7th grade in their history class starting to talk about this ancient Silk Road between China and Rome. So when you turn into 7th graders at about the middle of the school year, you're going to be thinking about this same Silk Road that I'm talking about right now. Okay? Okay, the picture back here behind the text kind of gives us a hint that there's a library involved. So when this guy here established the House of Knowledge in Baghdad, which is something else that you guys will learn about during your history studies next year as 7th graders, in 832, they invited this father of algebra to come to their city personally. And that's in Baghdad. How many of you have heard of Baghdad? Okay, Baghdad is a fairly well-known city in the Gulf Coast or in the Gulf there. So we've heard of it because of different things that happen in the news. Okay, If you ever wondered who invented the idea of zero, we can blame this same guy. He's the guy that thought up zero. Can you believe that the world was turning for that many years before this guy was born in 780 AD? That we didn't even think about a zero yet until he come along? I wonder what we haven't thought about mathematically yet that's going to come along in the future. Because if it was that long for him to think up zero, there's got to be things we're missing, right? Okay, so this opened up a whole new world of mathematical possibilities and complexities. Okay, so using the old Roman numeral system made advanced math next to impossible. How many of you have heard of the old Roman numeral system? Raise your hand if you have. All right, stand up if you have. Turn around in a circle while you're standing if you have. Everybody needs to wake up a little, so let's turn around in another circle, maybe jump up and down a second or two, and then sit down. All right. Okay, not yet, Rebecca. Okay, we're all sitting now again. The Roman numeral system is made up of letters, basically capital letters that represent digits or numbers as we know them, the Arabic numeral system that we use today. Using the Roman numeral system is very difficult to do calculations and different things algebraically. So this guy here made it so that we could use the system, the 0 to 9 algebraic, or not algebraic, what did they call it? Arabic numeral system that we use today. Go ahead and read that while I go shut my phone off. It's ringing. Okay, I'm 100% certain the person on the other end of that line wanted to talk to me about my car's extended warranty, but I don't feel like doing that, so I just hung it up. He initially used to calculate Muslim inheritance laws and then built more on the geometry of Greeks and developed the basic ideas many high school math students can recognize today in their geometry classes. Okay, so what did he use this algebra system for and these Arabic numerals at the very beginning? Yes. To make Muslim laws, to make Muslim inheritance laws. Inheritance means the monies or goods or valuable things that you pass from one generation to the next when someone passes, right? So they had to have a way to calculate all that stuff. So they went ahead and used that initially to use those calculations in their inheritance laws. I missed it. All right. All right, so in addition to math, he wrote a compendium on geography that lists the latitude and longitude of 2,400 cities around the world, as well as books on astrolabe and sundials, okay? And that's what they think he looked like, or basically maybe what he did look like based on drawings of the day. It's kind of pretty, if you ask me. Okay, and for 700 years after this guy died, people were still talking about him. European mathematicians cite him in their works, referring to him as algorithmy, something like that. The modern word for a complex mathematical formula, algorithm, is derived from his name. And the word algebra is derived from the Latinization of algebar, okay, part of the title of his most famous book, okay? So this guy here, he is the reason we are talking about algebra today. Or maybe, you know, if he wouldn't have come along, maybe somebody else would have picked it up and we would be talking about a different word meaning the same kinds of things. Okay, yes.
Is he smarter than Albert Einstein?
Was he smarter than Albert Einstein is the question, and I have no idea if anybody even knew how to do an IQ test in 780 and 800 AD. So it's hard to tell. It's a good question. It's interesting to think about. Okay, here is algebra. We're going to talk about starting today, chapter 5. We've been working along so far, talking about all kinds of different things. This is where I would like you to be on page 202 then. Okay, so I'm going to have you read that first passage at the very top of page 202 in your math book. And I want you to think through about what you think these blank spaces should have in them. Okay, as you're reading, and then in about a minute and a half, 3 minutes, maybe 3 minutes and 12 seconds, I don't know, I'll stop and have you guys help me fill in the blanks. You do not have to write this down, just be thinking it in your head so you're ready to answer some questions. Okay, algebraic expression is an expression that may contain blank. What should be that first blank? Okay, Sophie. Number? Number? Does everybody think number should be there? Yeah. Based on what's missing from what we have in our book? Okay. An algebraic expression is an expression that may contain numbers, let's put numbers, blank, and one or more variables. Yeah. Operations. Operations? Like a tonsillectomy or something? No, operations means like your plus sign, your minus sign, your multiplication sign, your division sign. Operations basically means mathematically what are you telling me to do, right? Add, subtract, multiply, or divide. Okay, so that first sentence reads like this. Algebraic expression is an expression that may contain numbers, operations, and one or more variables. Variables. Okay, what's the next word that we would put in the next blank? Brody. Okay, Brody just said that we're using that same letter that or same word we left off on. Variables are symbols that represent one or more numbers. Okay, so a variable really is just a letter from the alphabet that's being represented in place of a number. Okay, each number or variable by itself or product of numbers and variables in an algebraic expression is called a blank. Term. Okay, so that's how that reads in your book. Those are the words that I think are pretty darn important. about that very first passage in algebra in our book, okay? So let me try to help you make sense of all of this, okay? Because below there, they start talking about all kinds of other different vocabulary words that should blow your hair back. Maybe you haven't heard them before. Words like coefficient, variable, constant, and terms. Well, we've seen variable now, and we've seen terms in just the very first couple of sentences that we've read, right? Okay, so let's just think about this one simple, basic algebra expression. Okay, it's a simple expression. We don't have to solve it. We're just going to kind of dissect it and find out what we call all the doodads inside of him. Okay, so this 5 here, he is going to be what we would call a coefficient. Can anybody tell me why? Go ahead and look in your book. See if you can find anything about coefficients in there. And tell me why I would call the 5 in that expression the coefficient. I have a lot of hands up. I should have more though. Okay, why would we call that 5 a coefficient? What do you think, Mr. Klopp?
It's above the P.
It's in front of the P, he said. Yes, that is exactly right. Any number that is hanging out with a letter is going to be that letter's coefficient. Okay, that's just a fancy way of saying, dude, I'm hanging out with a letter. I'm a coefficient. Okay? So this number 5, the number 5 in that expression is the coefficient. What's the variable then? Everybody? P. The letter P is the symbol that represents one or more numbers in that expression, right? Okay? And he is our variable. What about this number 4 hanging out all by himself? We've never really called a number this before. What you got there? He's the constant. This guy here, he's called constant because he is not hanging out with any variables. He's got no alphabet next to him whatsoever. So in this expression, this guy is the constant. Okay, so the 5 is the coefficient, the P is the variable, the 4 hanging out all by itself is the constant. Now, this gets a little tricky right here. Terms. How many terms do you suppose are in this expression? I'll tell you. Here's one of them. Here's the other one. How many terms? 2 terms. Okay? Anything going on between operations is going to be considered a term, no matter how many letters and numbers there are hanging out there, right? So basically, if you go like this between every adding sign, subtracting sign, multiplying sign, or division sign, you're going to have a term, okay? So hopefully that'll start you out on those vocabulary terms that we need to get good at. Okay, here's something that we have to remember, and I'll be drilling this into your head throughout the next few weeks. A variable, a letter, right, all by itself has a coefficient of 1. That means that if I had, instead of this expression, if I have P plus 4, what's the P's coefficient? 1. That means that if a letter is all by himself, the coefficient hanging out with him that isn't written down, because you don't have to write it down, mathematicians are lazy, they don't write everything if they don't have to, is going to be 1. A variable by itself has a coefficient of 1. Does that make sense? Okay, so anytime you see a letter hanging out all by himself, his coefficient is going to be 1. Okay? As you guys know, I'm an animal lover, so I decided to kind of help you make sense of all this. As an introduction, we talk about puppy dogs, because I love puppy dogs, right? There's still a number there up there, yep. Okay, an expression for the weight of a Great Dane could be 40C, where C is the weight of the Chihuahua. So I'm telling you, this is the expression that we could use to calculate the weight of the Great Dane. Okay, here is what we're going to really start out with. I should have started here. Although they are closely related, a Great Dane weighs about 40 times as much as a Chihuahua. How many times as much? That means his weight is 40 times greater than the Chihuahua's weight, okay? Even though they're so closely related, they still can be that big of a difference in weight. So our expression is 40C, and I'm going to keep that for a moment. Oh, we went straight into dog's age. I'm going to back up then. Because we need to deal with that 40C first. I want to show you how we use that. All right, so what if my Chihuahua here, what if I put him on a scale? Here's the Chihuahua scale, and he's going to go stand on it. And the scale says that that Chihuahua is 3 pounds. Okay? So if the Chihuahua's average weight is 3 pounds, 40C really means, in this case, 40 times the weight of a Chihuahua C. Right. So that would mean this dude here weighs 112 pounds. Okay? 112 pounds. Probably heavier than some of you in this grade.
Not even a
Okay, yes, those dogs can weigh upwards to 110, 150, anywhere in between. Okay, we're going to switch from weight now because I don't like to talk about weight a whole bunch. We're going to switch from that to age. Please put your hand down. I'm giving a lecture. All right, dogs' age calculations. Okay, since the 1950s, a popular way to calculate how old a dog is in human years has been to just multiply the dog years that he's lived by 7. Okay, one explanation for this is because if you think about it, typically a dog lives to around 10 years, right? And we live to about 70 years. So the ratio is 7 to 1 if you simplify it. If you have 70 to 10, the ratio of 70 years for a human, 10 years to a dog. If you simplify it by dividing both of those numbers by 10, you get 7 to 10, right? No, you don't get 7 to 10, you get 7 to 1. Beautiful. That's why I think, and a lot of people think, that people have used this expression to calculate the age of dogs. Okay? It isn't very accurate. I've actually looked up, I don't know if this will take me to the website or not. I've actually looked up on the internet to find out if that's a really good way to calculate dogs' years and find out how old they are, and it actually isn't. There's a better way to do it, but it has to do with using logarithms and different things like that that we don't learn until we're in high school. However, a handy-dandy chart lives there. Sorry about the commercials. A handy-dandy chart lives there in the American Kennel Club site that gives you a grid here to show you, based on how heavy your dog is and how old they are in human years, how old they would be, how old your dog would be. So like my dog, Lady, she is 67 pounds. So she fits in this category right here, right? The 51 to 100 pound category. She is 5 years old. So I drop down to where it says 5 years old. And then I know that my dog, Lady, is in her 30s. She's approximately 36 years old, human years. Okay, so that was really handy. That chart is really handy because we don't know how to use logarithms. So we're going to just kind of back up a bit. If you're interested in finding out your dog's age, I love that chart. Go take a look at it and think about it. Okay, however, we have this then. We have a calculation to do. An expression then for the age of a dog could be 7n. That's the whole expression. How many terms are in that expression? One term. The word term means how many things are in between pluses and minuses, right? So 7n. With that information, if Tony, the Chihuahua, hi, I'm Tony. If Tony the Chihuahua is 4, and if Ezekiel, the Great Dane, I'm going to call him Ezekiel, okay, is 7, what is their approximate age in human years? So let's start with Tony's. 7n is my expression. How old is Tony the Chihuahua in human years? 4. He's 4 years old in human years. So I replace the variable there, the n, with 4, and I can find out how old he is approximately in human years based on the old way of doing it. How old is he? 28. He's approximately 28 years old. What about Zeke? Zeke, if we use 7n over here for the expression, and we know he is 7 years old, how old is Zeke approximately?
49.
Approximately 49. Okay, so one of the interesting things on that chart, though, is that the bigger the dog is, kind of the faster they age. Okay, so I'm going to go back to that chart real quick. How can I do that?
Dog age calculation.
Okay, it was right here. Okay, so you know that based on what we did to start with, the weight of a dog, right? Is that Great Dane going to be in this huge category over here, 100 plus category? Yes, and so if Zeke is 7 years old, okay, and about this heavy, he's not really, based on what we know scientifically and the Kennel Association, he's not really 49, he's more like 56. Okay, so but is it close? Yeah. Do we have to have an exact age in human years for our dog? No, but it kind of gives us a way to use expressions to talk about how we can calculate different things. So I thought that was pretty exciting, especially because it brings algebra into talking about animals. Shh. Okay, when you have questions, you raise your hand and wait until I'm ready to answer questions, okay? All right. So that is that. We're going to, instead of worrying about this right now, pretend this isn't even on the smartboard. Instead of thinking about this, we're going to think about, okay, there. Huh. I need a blank page on my smartboard and I didn't open anything ahead of time, so give me just a moment. I want you guys now, since we're done talking about this example, I want you guys to see more examples, okay? So in your book, I want you to back up one page. Back up one page in your book, please. Okay. On page 201, you're going to see some cupcakes and some cars and some shoes and a snake or stuff. Okay, those are some examples of things we can use algebraic expressions for to solve. Okay, so read that very first one in your head and think about where I could use a number and where I could use a variable, a number that we don't quite know the amount for, and possibly make an expression. Because we're doing this because some of the questions we have to do today for our homework assignment are just as very similar to this, okay? So it said work with a partner, but I didn't let you work with a partner, but I almost died because I almost fell over my chair and it was funny and you guys missed it because you're in different rooms. Huh.
Not funny. Put it on.
This is Franzen's class, let's be quiet. All right. All right. I'm going to go ahead and read that first one, A. You've received $24 for washing cars. How much do you earn per hour? Okay. So how can we write an expression that would help us solve this problem? Think about it. We need at least one term, right, for an algebraic expression. And we only know one number, right? We know this number. Okay. What else do we need to know a number for? We've got a money number. We need a number for something else. We need a time number, right? Time in hours, right? Okay, just like I said, hey, if we're talking about the weight of the Chihuahua being 40 C, the C is the Chihuahua's weight, the Dane is 40 times heavier. I went ahead and used the number I knew, 40, to be the to be the, what do we call that when you're hanging out with a number and you're a number hanging out with a letter? What's that number called? He's a coefficient. So my coefficient here automatically I know is 24. Okay, and then I get to pick any letter in the world I want to pick to be a letter that represents time in hours. Okay, and would I multiply, add, or subtract, do you think?
Multiply.
I would multiply. 24 times however many cards I can get done in the hour will give me the amount of money I'm making, right? So what if you wash 3 cars?
It doesn't matter because it's getting paid for per hour.
Okay.
$4, $6 for
How long will it take you to wash the cars?
Okay.
$8.
You're saying how long will it take you to do the
So
cars?
you're saying that $24 per car is not what we're getting. It says here, you receive $24 for washing cars.
Per hour.
Cars. How much do you earn per hour?
$8.
8?
What?
Okay. So they're asking, is it cars or is it hours? Are you earning per hour or per car?
Per hour.
$24 just for.
Okay. Okay, so what if this is my per hour payment? $24 per hour. Let's just say what if. Okay. What if you work 7 hours? Okay. What if you work 7 hours washing cars? Yes.
$198.
He says 198. What did he do? He took 24 times how many hours? 7 hours to get, ignore that, to get, what did you say? 198. Okay. Beautiful. So it had nothing to do with how many cars, did it? Because this variable here that we're worried about is time in hours. We don't have to worry about how many cars. All right, so let's check his math though. Okay, 7 times 4. 28. 7 times 2. Plus 2 more. Okay, so he's pretty darn close, wasn't he? So 168. Is it okay? Is it okay to be a little bit off if you're just doing mental math and then go back and check it? Yeah, this is a safe place to make mistakes. Mathematics is a safe place to make mistakes. Go back and check for accuracy each time though, so you can be sure that your answer is good. Okay, let's look at that next one. You buy 5 silicone baking molds at a craft store. How much do you spend? Oh gosh, we've got to write an expression for that. Not for the kitten. You buy 5 silicone baking molds. Our coefficient is 5. How much do you spend? So we know how many. We just don't know how much, right? So the coefficient is 5, and the amount of money per is what we have to work with. So I can pick any letter in the alphabet. I'm going to use the word D, or not the word D, but the letter D. And notice I've been using small, not capital letters. Okay. So 5D. So what if the cost is $1.50 per? Okay. So then we do 5 times $1.50, and we get our answer. Okay. But really, this is what I'm asking you to do for your questions today. You do not have to do this part unless you really want to. And in fact, for the ones that you're getting, I don't think that you'll have all of the information to answer the questions with. Okay, so am I looking for answers today, or am I looking for you to write expressions today?
Expressions.
I want you to be able to write expressions. Okay, so those are some examples of what we will be doing for some of our questions today. So let's kind of skip ahead now, because I think we've gotten enough info to get those first 16 questions done, which is what our assignment is. So now we're on page 206. And I have to figure out where I'm at in here. 206, beauty, okay. Okay, this is some information about what the questions are, right? So we have 3 questions that are percent problems. We have 4 and 5 that are missing quantities using double number lines. We have 6 through 9, which are dividing mixed numbers. So basically, most of our work today is reviewing stuff we've done before we even went to Christmas break. So we're dusting off our brain, right? This is all review. So you'll have to look back in your book to figure out how to answer some of those questions. Can we take a moment right now and think about how it is we would look in our book and find where we can look for percent problems? Where in our book, what kind of tool at the very front of our book could we use to figure out which page numbers to go back to? What's that thing called at the very front of your books?
Page.
It's a page finder? Okay. Wouldn't it be called the table of contents? Okay. So let's look at our table of contents and look for the keyword percent. All right? Because we might have forgotten how to find percents and answer those first 3 questions. So look in your table of contents. What page numbers are next to the percent in your table of contents? Yep. Looks like it starts on page 167 and goes clear to 182. So if you're not sure how to do those problems, you're going to have to review these pages and kind of look and see what you can figure out and read back inside of our textbook to answer those questions for. Okay? Now, questions 4 and 5 are missing quantities using double number lines. My goodness, which chapter were we talking about double number lines in? If you look really carefully on your homework assignment page 206, it actually tells you where you need to look back to, I think. I lied, it doesn't. Let's look at our table of contents again then. Table of contents. What pages would we talk about double number lines on? If you can't find it there, what other tool inside your math book could you use to find the keyword double number line? It's at the back of the book. The index. The index at the back of the book might be where you'll find double number lines, but I think it's in the table of contents at the front. Let's look. Whoever's talking needs to make it stop. I'm even going to look with you guys. Can it be past chapter 5? No, it can't be past chapter 5. It has to be 4 or earlier. And I'm not finding it in the table of contents. So what was that? What was the name of that thing in the back of the book again? Index. I'm going to go back to the very back of the book where there's a whole bunch of words, but they're not defined. It's not the glossary. It's called the index. I'm going to look for double number line back there. Double bar graphs, double number line. Ooh. It says page 144 in our textbook would be a good page to look for that, or 121, or 124. Do you see how I know where to go in my book to help me answer those questions? Okay, I'm going to use that index. I'm going to make note of the fact that if I don't remember how to use those missing quantities using double number lines, I can go back there. Okay, finally, for these questions on our homework assignment, questions 6 through 9, we're dividing mixed numbers. So dude, didn't we just have a big packet that we were told to put in our folders from Mrs. Franzen that had cheat sheets for adding, subtracting, multiplying, and dividing fractions? You could use that set of notes, or Is there a part in the book here where we talked about dividing and stuff of yeah, mixed numbers? Well, okay, it wasn't chapter 1. I'm looking back in my table of contents again, by the way. It was in chapter 2, it looks like section 2.2, all the way through section 2.3. So I would want to go through and look at pages 53 all the way through pages 62 to find instruction on how to refresh my memory and how to do those types of problems. Or use those cheat sheets that Mrs. Franzen built for us and we took notes on. Okay? All right. So that's what we're going to do. We're going to use the tools in our math book to help us with these review problems to dust off our brain cells. All right? And you guys, I'm erasing this because you guys don't need this written down for you. You can do it yourselves. Okay. We've already done this part. We've looked at page 201, talked about how we're going to write some expressions. Now, if you look closely at the last 4 questions, I lied, last 3 questions, 14, 15, and 16. Read the directions for those last 3 questions in your head right now. We're on page 206 and you're reading the directions for the last 3 questions, 14, 15, and 16. Awesome. You've done reading them? I'm going to read them too. Identify the terms, coefficients, and constants in these expressions. Okay, so you're going to notice that we've got expressions. And do we have to solve them in any spot? Does it say evaluate, solve, find the answer to these? No, it doesn't. This is a vocabulary activity for questions 14, 15, and 16. So put your pencils down for a moment. If you already have your dry erase markers and your boards, that's great, but you really don't necessarily have to use them yet, unless you really want to. Okay, are we ready? Okay, I'm gonna actually do this because I see some people drawing instead of thinking. Put your markers down and just listen for the first example, okay? All right, so the first example I have up here says m plus 3 plus 2n minus 2. How many terms are in this expression? Somebody said 4. Let's check. All right, I'm going to change colors. Here's one, the m. And in between this plus sign and this plus sign is another one. And in between this plus sign and that minus sign is another one. And then there's this guy here hanging out by himself. There are indeed 4 terms in that expression. Okay, how many of those terms are constants? How many constants are there? Remember what constants mean? They're the dudes hanging out with no other numbers or letters, right? Okay, there's 2 constants. People are using their peace sign to show me there's 2 constants. Remember, constants means numbers that aren't hanging out with letters, okay? There are 2 constants. How many coefficients are there? Careful. There's this one here that we don't see. Why don't we see him? Because if a variable is all by himself, that means the constant is 1. And then we see this guy hanging out with the n because he's a different number other than 1. So there are 2 coefficients, 2 coefficients. And the coefficients in this case would be the number 1 and the number 2, right? Because the 1 is there, we just didn't have to write him. Okay? And then finally, how many variables are in that expression? How many variables? Remember, variables are the letters. I'm seeing peace signs again. That's right. There is an m and there is an n. There are 2 different variables in that expression. Okay? So basically what we're doing for questions 14, 15, and 16 are identifying the different parts of the expressions like that. Okay? So let's do it a little differently this time. It says number of terms, there are 4. Okay, what are the constants in that expression? 3 and 2, right? As you grow later on, we're going to use the integer -2, but for now, don't worry about that. Okay, so coefficients in this case, the coefficients were 1, the one that was hanging out with the m, and the 2 that's hanging out with the n. So those are the two coefficients. I'm going to just use the word and again to keep things the same. And the variables were m and n. Okay, so let's do this next one. How many terms are in this guy?
2.
There are 2 terms. Which one of them are constants, or are there any constants?
16.
There aren't any constants because none of those numbers are by themselves. Which ones are the coefficients?
2.
There's 2 of them. There's the 16 hanging out with that first x, and then there's that 2, technically -2, but 2 hanging out with the second x. How many variables are there? Don't get tricked. Don't get tricked. How many variables are they? They're only more than one variable if they're different. Okay? And so in this case, there's only one variable. What is the variable?
X.
The letter x. Okay? So do you see how we're doing these? We're just identifying the different parts of those expressions. Okay? Now is when we're going to practice. So you can open your marker up and be ready right now. Okay, I know I'm using most of our time up, and I do apologize, but I know you guys can do these in your study hall. Okay, so copy this expression right now. Copy it on your dry erase board. All right. If my directions are to identify the terms, coefficients, and constants in this expression, okay, which ones are the terms? Circle them. Circle your terms. Okay? Circle your terms. How many are there? Everybody with your fingers, show me how many there are. 2, right? Okay, I'm going to kind of give the hint here. Very good. You should have done that. Okay? Now, put a star above the coefficient or coefficients if there's more than one. Put a star above the coefficient. Remember, coefficient means I'm a number that hangs out with a letter. Okay? And then, finally, underline any of the constants. Well, do we have a constant? Yes, we do. This dude right here is my constant, isn't he? Okay? So that's kind of how the next one will go. So you can either leave that on your paper if you've left yourself enough room or you're dry erasing, or you can erase it. I'm okay either way. We're going to do another one though. You ready? Okay. Circle each term. First you're going to copy the expression, and then you're going to, for me, you're going to circle each term. Remember, terms are what's happening between adding and subtracting. Okay, would you show me what you got? I know I can't see everybody else's, but I can see your guys' if you just show me. Okay. All right, all of us get this. This is awesome. Each term, I'm going to circle each term. Okay. Now put a star above the coefficient or coefficient. A star above the coefficient or coefficient. Very good. Very good. Okay, I'm seeing a lot of people doing this. This number here, the 3, who is hanging out with the letter, he's a coefficient. Very good. There are no others. Now underline the constant. In this case, there's 2 of them, so I'm going to make this plural. Underline the constants, please. You guys are getting this. Good job. So my constants in this case are these numbers here that are not hanging out. They are not hanging out with letters. Okay? Same thing. Copy this expression. Z to the second power, which is it's an exponent. We know about exponents. You're good. Can we square a variable? Sure we can. Okay? This one's a little tricky, but I'll be nice, I promise. Circle each term and then show me. Yep. Good. Okay. So they've circled their terms. They've circled these terms. There's 2 of them. Now put a star above the coefficient. There's only 1 of them. I lied. There's 2 of them. It's just that you can't see 1 of them.
Oh.
I almost tricked my own dang self.
Oh.
Remember, if a variable is by himself, the coefficient is this guy here. Okay, so we have to put a star above the coefficients, and so those are our coefficients. The word coefficient means the number that's hanging out with a letter. The number hanging out with a variable is a coefficient. Now, underline the constants. Is there anything to underline? No. In those 2 terms, there is no number just hanging out all by itself. All of the numbers we have are hanging out with variables. So in this case, there is not a constant. Okay? So with that, I think that's our last example. I might have one more, I'm not sure, but we're almost out of time. Okay, your job then is to do questions 1 through 16 on page 206 for homework. Okay, 1 through 16 on page 206. It's in your book. So you just need your book, a piece of paper folded into 8, number it 1 through 16, and do those 16 questions as homework. Questions? Any questions from the peanut gallery? Rebecca?
What is the app called for being calculated your
That's called the American Kennel Society. That's where I found that information. Okay, everybody, it's so nice to be back to school, and I hope I didn't overwhelm you guys with work today. But if you need any help, remember that text-free hotline I have, 406-478-6242. I'm up until 9 each night. So if you're really stumped, can you text me? Yes. Okay, get ready for your next class. Thank you for coming to math today. Yeah.
Or 13, or 14, 15, 16. Are we just